Good afternoon, everyone. Today I'm going to talk to you about Infusion, which is a live programming system, a substrate that I've been working on for a few years. What is a substrate, you may ask? Some of us met earlier this year at the first substrate workshop in Prague and had some debate about this. To me, a substrate is a kind of material for software that allows the intentions of different authors to be related to one another. Jonathan Edwards highlights two important aspects of a substrate. Firstly, that it bridges the distinction between documents and applications, and then also the distinction between programming and using. My aim with Infusion is to empower communities to take ownership of their own technology and expressions and cooperate on related aims without having to rewrite each other's words. I'll start by demonstrating a simple to-do list application, and later on I'll show how it can be adapted live to have new capabilities layered on top of it. Here's the basic app, whose markup and logic have been borrowed from a close sibling substrate, the WebStrate system built by Clemens Klockmoser and his team at Aarhus, as well as some of their clever techniques for embedding an IDE in the document model. As you can see, the interface behaves like any regular app, only with a single include you can inject an edit button, which discloses the IDE interface. Here it is. As you can see, the disclosed IDE is also written in Infusion and will enjoy all of the benefits of adaptation. An Infusion application is organized into layers, each of which is given a color in the IDE. Here we've just got 3 layers representing the overall app. At the top, the list and an individual item. Layers are JSON-like structures which get composed by a dictionary merge process to form component instances in the substrate. In this simple app there isn't any layer merging going on, but just containment, where the app layer has a $component record saying that it has a to-do list subcomponent. The to-do list layer here has a record saying it has a list of to-do items as children. For representing view components, we house the JSON layer definition announced with fluid.def at the top as a top-level HTML document which conveniently collects markup, styling and behavior in an SFC, a single file component structure, which may be familiar to you from frameworks like Vue.js and Svelte. In the bottom pane, you can see the substrate tree itself. Each node in the tree is colored according to the layer where the definition responsible for it being in the tree appears. One of the most important aspects of Infusion development is that the rendering process is not simply a one-way function. It establishes a correspondence between the visible application and the substrate. And because each node in the substrate is colored for its own layer provenance, this means that we can reconstruct the complete reason for any user interface element being the way it is, with exciting consequences we'll see later. But to start with, see as I hover over each component node in the substrate. At the same time, I see highlighted in the UI the corresponding UI element. I can also run this in reverse by clicking the Inspector button up here in the IDE. I can trace backwards from the UI into the substrate. The entire interface is live. By editing any part of the SFC definition, I can update the application. So, for example, I will take the title here of the overall application, and you can see as I update the text in the SFC, the application itself up here updates in sync. Infusion is currently built on a standard reactive signals library called Preact Signals, but a rewrite is needed to support more forgiving reactive primitives. Because the IDE itself is implemented in Infusion, this is also malleable in the same way. If I untick this box, Filter Framework Layers, I get to see the complete layer definitions not only for the framework, but also the IDE itself. In this light purple at the bottom, you can see foundational layers like fluid.component, and in darker purple above you can see IDE layers like fluid.editor. By hovering over this expanded substrate, now you can get to see how the IDE itself is laid out and then find your way into customizing it. So, for example, I can find the editor pane up here and the layer list, which we've just been browsing, and then the menus up there. So if we open up a substrate pane, we can change its layout a bit. Let's open up this substrate pane here from the substrate itself, and then we can tinker with this margin here a bit and say, well, we want a bit more indentation in the substrate tree, like that. Okay, so let's untick that and go back to the application. Now, in amongst the other substrate layers is a special kind of layer in yellow, which holds the data layer which backs up this application. So you can see here one block corresponding to each of the to-do items, and I can open up the JSON definition here. This is editable as JSON like the rest of the application, with bidirectional live updates. So let's toggle the state of this completed item from the JSON. There, you can see it's now become uncompleted, and correspondingly we can check this, updating the JSON there. So, before getting to the next demo, I want to talk about an issue which is special to Infusion's model, which is Ted Nelson's notion of transclusion. Ted's definition was the same content knowably in more than one place. But what does this definition help? I think there continues to be an irreplaceable role for software artifacts in representing connections between human communities. Ted Nelson didn't think the web delivered properly on his vision for transclusion. An iframe can only include an entire document, and in a way which interacts gracelessly with layout. Instead, I think we need to improve on his vision. This limited kind of transclusion could be called insulating transclusion, where no relationship is established between the included material and its context. Infusion supports transclusion with overlay, where the material is imported into your substrate's scope, and you get to make choices by overlaying any changes you want on top of it. Considering this application as a document shared amongst communities, with different fields and capabilities they want in lists, we'd like to take the base community's app and infuse it with the ability to assign issues to different people and then filter the list items by assignees. This kind of facility gave rise to the name of the Infusion system. So this next is also an example taken from the Aarhus team, in this case Marcel Borovsky's VARV system. In this elaborated base version of the app, we've inherited the same layer definitions for to-do item and to-do app, and added definitions into to-do list to support filtering of items. So here is the SFC, which simply represents all the original material plus a filter which can filter on something. Now, in this base app, we can just filter on the completion status of an item. So here, for example, are all the completed items, and so on. However, more layers are now available in the system, which represent the capability of assigning an item to someone. This capability cross-cuts the application at 3 levels, which are infused into it by checking this assignee facet checkbox here. Firstly, there needs to be a registry of assignees at the to-do list level, and the ability to assign to them. Secondly, the to-do list item itself needs to be able to represent the assignee and control over it. And finally, there needs to be the ability to choose which assignees to filter on in the filter bank. So when the checkbox is checked, we see these 3 additional layers appearing in the substrate in their own different colors, and we can now use the enhanced application features to assign and filter items. So you can see this extra filter control has appeared, and the ability to filter items based on it, and each item has also acquired this selection control. So now we can see that these layers can be cleanly disentangled from the system by unticking the box and see it back again from the original author's point of view. And you can see that the substrate now closes up, showing that the additional layers have been withdrawn from the system. So how is this an example of transclusion? If we go to this base index file for the application, we can see how its imports are organized in blocks. Firstly, an import for the framework itself, then a URL base and imports for the base application here, and then the bottom down here are all the additional imports for supporting assignment. So given Infusion always allows you to track parts of a UI back to their layer definitions, these will always be accessible from the point of use. So mixing in your own functionality to an existing app will take the form of grabbing references to these layer definitions and just adding your own ones after them. A future syntax might let you import an existing application's layers wholesale, together with providing an interface for managing layer definitions and their sources. The final definition I want to show exhibits how Infusion goes beyond the model of centering computation as the fundamental activity of software, and instead operates reactive composition primitives on aligned state. Many of you will be familiar with the perplexing activity of editing your highly performant static websites through the inexplicable and invisible template macro systems of site builders like Hugo or Jekyll. It's very hard, given something on screen, figuring out exactly how it got there and which partial you need to edit in order to make it look different. Here's a simple 2-page example taken from my own website, which, when expressed as Infusion layers, doesn't involve any computation primitives. So here is the definition of a full post, and this simply composes as JSON a navbar, a header, a post, and a footer, which correspondingly we can highlight for each of these posts in the substrate view. These SFC definitions just contain markup, CSS, and JSON expressing composition. In this kind of configuration, Infusion is not Turing complete. By pressing the magic wand button, we can perform direct editing of the UI, which through provenance tracking routes the edits to whatever layer is responsible. So if I start editing the footer here, we can see not only do the matching pieces of footer update in the other post, but you can see that the SFC definition has been updated in step. Through systems like this one, I'm hoping to close up the gap between WYSIWYG site builders like WordPress and Squarespace that imprison the content of regular citizens in walled gardens, and the static site builders that let technical elites host highly performant, open content on free infrastructure. Before showing some community work, here are some links to theory. Infusion is thought of as operating a reactive relational algebra, both horizontally, relating different values in the substrate's address space, and vertically, relating the rendered interface to the substrate. The horizontal part of this algebra positions Infusion as a kind of integration domain in the sense of Stephen Kell's legendary 2009 paper, The Mythical Matched Modules. In 2018, I wrote an onward paper on the open authorial principle, which lays out some of the theory underlying Infusion's model for composing expressions of different authors. In that paper, I hadn't yet fully conceptualized the distinctions between reuse, which is traditionally considered an economic proposition, and transclusion, which is a relationship of authors. This is a political project as much as a technical one, and before finishing, I wanted to show some work that had been built with older versions of Infusion supporting communities and expressing their relationships. Firstly, the Chaethicum Ecocultural Mapping Project provides a map-based interface which connects stories of indigenous communities around Galiano Island in the Salish Sea near Vancouver, together with biodiversity data collected by naturalists and citizen scientists in the area. This is a panel-based story map with some panels devoted to ecological regions like forests and freshwater, as well as specific features like rivers and caves. Secondly, the Oregon Bee Atlas has collected thousands of observations of bees on plants from experts and volunteers, and wants to advise landowners on seed mixes and land use, as well as helping volunteers see and plan their contributions. The dynamic ribbon graph makes it easy to explore the interactions of different combinations of plants and pollinators, filtered for regions or seasons. Whilst this older version of Infusion didn't offer much in the way of live malleability, its compositional structure was quite similar, and this was helpful in composing expressions written in different dialects such as R Markdown and JSON. Thanks for your attention, and I'd love to hear what ideas this sparks off in you and suggestions for directions you think this work could be taken in.